Guess who? How's it going, guys? Of course, I miss you guys so much. We had a well-deserved spring break. Again, I don't know about you, but I was so exhausted with this iPad. Didn't want to look at it. Had a great break. I hope you all did the same. I hope you're all staying well and healthy and safe. I'm going to go over the 6.5 notes with you guys. Remember, I stopped with the dihybrids because I did not want to tackle too much before spring break. So now that we are finally getting into it, most of you have done well. You watched the Amoeba Sisters, you did that worksheet, you understood it. Some of you sent me emails to tell me that you needed a little bit of help. Please make sure that you're understanding. If anything, go back and listen to my lecture on monohybrids. That was all of this information that you're seeing on my screen now. But what I'm going to do is I'm actually going to go over this dihybrid. So remember, di means two, and I did not underline that like I normally do. But remember, di means two. So we are, in this case, talking about two traits. So what that means is we're going to end up with two different alleles. Remember, alleles are different forms of a gene, so we're going to think alleles, different letters. So we're going to talk about two different letters, both uppercase and lowercase. In turn, we're going to have four different options. Uppercase 1, lowercase 1, uppercase 2, lowercase 2. So again, a dihybrid, it's going to show you either both of the traits appearing together or one of the traits appearing and the other one kind of being a carrier, kind of hidden. So our example goes off of Mendel. Remember, we talked about Mendel, the father of genetics, and he was working with pea plants. So our examples here, we're going to talk about yellow round, yellow wrinkled, green round, and green wrinkled. Remember, yellow is our dominant, and round is our dominant. So with peas, yellow, round, pea plants or seeds or pods are dominant. Green and round, or sorry, I said that wrong. Green and wrinkled are recessive. So our two dominants, yellow and round, our two recessives, green and wrinkled. When we're looking at a dihybrid, what we're actually looking at is the F2 generation. So we have a parent generation that starts the original. We take that parent generation and find out what our actual traits are going to be for the outsides of the Punnett square. So what I did here is I took an example of pea plants out of the textbook. So I just used figure 5.5. So what we're looking at is the parent generation. I highlighted the parents in yellow. So this circle, that's big Y, big R, little r, and this big Y, big R, little r, is our parent generation. So what we're going to end up doing is we're going to take the cross of that first to figure out what goes on the outside. I color-coded it as well. So you have your F1 generation is going to be highlighted in red. That's here. That's what's going to go across the top and the side of the Punnett square. And then I have the F1 generation in blue and the F1 generation top in the blue and F1 generation side in the green. So if you remember from the Amoeba Sisters worksheet, they talked about you doing the FOIL method. So that's the first, outer, inner, and last, which comes from math. What I did is I always say in my head 1, 2, 1, 2, and then 1, 2, 1, 2. So for the first generation, the parents that they gave us big Y, big R, little r, and then they gave us big Y, big R, little r. What we're looking at in this case is two heterozygous for both. What I'm going to do is I'm going to take each Y and R and I am going to give them their own numbers. So I'll do it this way. I will call this one 1, this one 2, this one 1, this one 2. Same thing here. This one 1, this one 2, this one 1, this one 2. So we're going to keep these separate. This one section, P generation, F1 generation, F2 generation, I'm going to keep that separate from what's crossed here to the right of the actual cross sign. So big Y, little y, big R, little r. It's going to be our 1, 2, 1, 2. So we have one Y from mom, one Y from dad, one R from mom, one R from dad for both. Then we're going to go into our FOIL method. It's going to be our 1, 2, 1, 2. What we're going to do again, FOIL, I'm going to take 1 with 1, 1 with 2. Then 2 with 1, then 2 with 2. That's where this information comes from here, the F2 generation. So if I take 1 with 1, that's going to give me this one with this one. That's a big Y and a big R. If I look back over here at my highlighted blue, what do I have? Big Y, big R. That's my 1 and 1. Then I'm going to come back over here and I'm going to do my 1 and 2. So my 1 Y and my 2 R. So that's big Y, little r. Up here, my 1 with my 2. That's big Y, little r. Then I'm going to do it again. I'm going to go my 2 with my 1, getting that from down here. That's going to be my 2 with my 1, which down here it's labeled a 3. So that's going to be little y, big R. So that's my 2 with my 1. And then the last one is going to be 2 and 2, which is little y, little r. 2 and 2. So if we look at our possibilities, we've got same thing on the sides and the top for both the highlighted green and the highlighted blue. Why? Because our parent generations are the same. When we're doing our genotypic or phenotypic ratio, what we're going to do is I'm going to go back up to where I have my example. I'm looking for how many yellow round peas I have. Yellow round, I have to have a big Y and I have to have a big R anywhere within the combination. So big Y, big R, 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 not there, big Y, big R, not there, big Y, big R, big Y, big R, not there, not there, big Y, big R, not there, not there, not there. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that ratio so far is going to be 9. And that's yellow, round. Then I'm going to look for how many yellow wrinkled, dominant recessive. That's going to give us right here and right here. That's a big Y, little r. There's a big Y, a little r. There's a big Y and little r. So that is a 3, big Y, little r. And then how many, what's my next option? Green round. So little y, big R, little y, big R, little y, big R, little y, big R, and that's it. That's another 3, little y, big R, and then 1. That's my final one there. 1, little, little. My genotypic ratio would be 9 to 3 to 3 to 1. Phenotypically, we can look at it and it gives us the pictures. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 yellow round peas. There are 3 yellow wrinkled. There are 3 green round. And then there's 1 green wrinkled. And again, that's physically just looking at the pictures, looking at what we actually have. 2 things to go over. Again, ratios are determined basically whatever you're given in that Punnett square. But they're always written the same. You always go with your dominants first. In terms of a dihybrid, over here, you're going to go dom first, dom recessive second, recessive dom third, and recessive last. That's the order. And again, I got that over here. Dom, recessive, dom, recessive, with your example of our yellow round, yellow wrinkled, green round, green wrinkled. Law of independent assortment basically is like the separation, again, independent assortment. We're assorting things on their own. So they can stay alone, they can stay together, or they can be alone. And that happens during meiosis. And again, that's just a definition. And then probability, we all know probability, 50-50 chance when it comes to most of our genetic stuff. Again, 50-50 chance of being male or female. 50-50 chance of being yellow or green if you're a pea, tall or short with height. Let me see, and so on. I'm going to stop there. Again, I will leave this for anybody that wants to take a screenshot. I did this before. This was in a lecture. I'm going to go ahead and end this for the quick 6.5 dihybrid notes. And then my next video, I'm going to go over the worksheet, the dihybrid worksheet practice.